This is video 11, and in this video we are going to talk about some of the theoretical approaches to Pavlovian conditioning and try to unpack some of the proposed underlying processes that may be operating. So the first theory that I want to discuss here is the stimulus substitution theory, and before we do that, we have to consider what's happening. Why have we evolved to be able to make these kinds of associations? To associate a CS with the US, and then the outcome of that is that this new stimulus, the conditioned stimulus, is capable of eliciting a response when it wasn't able to prior. So why do we have this ability? And in more than that, what is learned? Pavlov speculated that what is happening, and this is based, of course, on the data that he was producing in his own laboratory, and this theory survived for many years. It's now come under challenge in the last 20 or 30 years or so. But Pavlov speculated that what's happening is a form of substitution. That during classical or Pavlovian conditioning, we have a stimulus substitution that is operating to create this new acquired reflex. So the stimulus substitution theory is as you might imagine it would be. The theory states that it is a theory of classical conditioning that proposes that the conditioned stimulus can substitute for the unconditioned stimulus. So what's happening during Pavlovian conditioning is that presentation of the CS followed by the presentation of the US, a connection is made, an association is made. And what results of that is a conditioned response that mirrors very much the unconditioned response. In all of the examples that we have discussed to this point, one thing is the same. And that is the conditioned response and the unconditioned response are similar. They're not identical. There are subtle differences in terms of the overall strength, the latency with which they are elicited, and so forth. But on the surface, if you just examine the response itself, in all of the examples that we have discussed to this point, the conditioned response and the unconditioned response are the same. Salivation to food, salivation to tone. Knee flexion to a tap on the patellar tendon, knee flexion to the presentation of a light, or eye blink to an air puff, eye blink to the presentation of a tone, and so forth. And so in every case, we have the conditioned response and the unconditioned response are similar. Now, assuming for the moment that that is always correct, and we will challenge that, but let's assume for the moment that that is correct, how might we theorize or conceptualize what is happening to create that outcome? And so we're essentially asking, what are the possible pathways? What pathways exist between a CS and a US and the eventual response that follows? What possible pathways could be operating? So assuming for the moment, again, that the stimulus substitution theory is correct, that throughout the course of Pavlovian conditioning, the CS can come to substitute for the US. And in so doing, it creates a reflexive response similar to the UR, or the unconditioned response. So let's think about these pathways. So we have these, and this is similar to how Pavlov conceptualize these things. And so to the right of the screen there these are merely just theoretical pathways that could potentially be operating somewhere in our nervous system. Pavlov is very physiologically oriented, and so he theorized that there were areas or regions in the brain that actually made and forged connections with other areas of the brain. He speculated that there were stimuli regions of the brain and there were response areas of the brain, and that there were innate reflexive connections already present in the brain at birth. These are innate reflexive responses. So, for example, food, which is an unconditioned stimulus, will elicit naturally, innately salivation. So somewhere in the brain, there's a pathway that reflects that innate reflexive response, such that when food is placed in the mouth, it elicits salivation. And so examination of that diagram there in the upper right-hand corner, the unconditioned stimulus in Pavlov's traditional paradigm here, the unconditioned stimulus is food, and the unconditioned response is salivation, and that is present at birth. Now, when we pair other stimuli, a tone, a light, what have you, with food, we can start to create additional responses, or similar responses rather, to additional stimuli. And so how might those connections be forged? So the first one that could be operating is referred to as the SS pathway, the stimulus-stimulus pathway. What this implies is that there's an indirect pathway between the conditioned stimulus and the conditioned response. And how it forges that pathway is it works with the pre-existing US-UR pathway. So once again, remind yourself that the unconditioned stimulus, unconditioned response pathway is forged and there at birth. And that as one starts pairing conditioned stimuli with unconditioned stimuli, if this connection operates indirectly through the SS pathway, one would think that when you pair the CS with the US, it is capable of itself of forging a connection with the US. And so let's go back to Pavlov's paradigm here. We've got a tone, we've paired it with food. Food elicits salivation. And so the top part here, food in the mouth elicits salivation. Salivation to food in the mouth, food in the mouth rather, is an example of an unconditioned response. A tone, however, is a conditioned stimulus, and that after numerous pairings, according to the SS pathway interpretation, the tone is a conditioned stimulus. It is capable of forging a connection with the unconditioned stimulus. So the tone connects with the food center of the brain, thus activating the food center of the brain. And once the food center of the brain is activated, it innately and automatically activates the salivation part of the brain. And so what's happening in the SS pathway is that once this connection between this new novel stimulus, in this case a tone, which is serving as a CS, is capable of creating a connection with the brain center responsible for the unconditioned stimulus, or receiving information from the unconditioned stimulus, once it activates that, this pathway is off and running, because then that activation innately activates this region, and now the organism is salivating, not specifically to the unconditioned stimulus itself, but to the conditioned stimulus. And so the SS pathway is this indirect pathway. Presentation of the tone and pairing with the unconditioned stimulus of the food results in this connection here. Once you activate this, it necessarily activates this, and then once this is activated, it innately activates this. And so when you're talking about a conditioned stimulus creating salivation, it's activating the same brain region, but depending on whether this brain region has been activated by the unconditioned stimulus or by the conditioned stimulus, it is differentially labeled as either the unconditioned response or the conditioned response. But by this model, or by this interpretation, it is coming from the same brain region. And so if you put food in the mouth of the dog, it will activate this brain region, which will automatically activate this brain region, and the dog begins to salivate. If, however, through Pavlovian conditioning, you pair the tone with the food, and then you do a probe trial in which you sound only the tone activates this brain region, which has already made a connection with this brain region, activating this, thus activating this. In that case, we would refer to this activation as an example of a conditioned response, or CR. So this is the SS pathway, the stimulus-stimulus pathway, which implies that stimulus substitution, and therefore Pavlovian conditioning, operates through this indirect pathway. And essentially that the association that develops occurs between the two stimuli. The alternative interpretation is the SR approach, or SR pathway, stimulus-response pathway. And what is implied in this interpretation is that we still have the same players operating here. We have a CS node, we have a US node, and we have a UR node. sticking again with the Pavlovian paradigm here, this node, this USUR node, food in the mouth, elicits salivation. This is present at birth. This is a reflexive response that all members of the species elicit, so this is still present here. But the differentiation with the SR pathway is how this area of the brain is activated by the conditioned stimulus. And so pairing of a tone with food, and therefore eventually leading to salivation, what's being proposed in this model is that there is no indirect connection, or rather indirect pathway via the US-UR link. What is implied is that once a CS has been associated with the US and the corresponding UR, or in this case salivation, has been elicited, what happens is that the CS node, or the area of the brain, actually begins to associate itself with the reflexive response that has been elicited. And so it acts directly, or it connects directly with this brain region. So a tone is sounded, it is associated and followed by food. Food elicits salivation, and what happens is that the tone begins to be associated with the salivation itself. And so it's a direct association. It doesn't go by this indirect SS pathway. It forges a direct pathway from the CS, the stimulus region rather, directly with the reflexive response or unconditioned response region. So that's why it's referred to as the SR pathway. It is an association between one stimulus and a reflexive response. When, of course, this is elicited based solely on the presentation of the CS, when you conduct probe trials and present the tone to assess how powerful it is as a CS, any response that is elicited by this CS, of course, is referred to as a conditioned response. But again, we're talking about stimulus substitution here, and that the reflexive response is still being elicited by the same brain region. So depending on whether it's elicited by food or by tone will determine whether the reflexive response is labeled an unconditioned response or a conditioned response. But according to this model, they are being elicited by the very same brain region. So those are the two pathways, an indirect SS pathway and the direct SR pathway. And so, now that we have an understanding of those two pathways, the question is then begged, which one's more accurate, or which one seems to be operating in Pavlovian conditioning? And so a very clever study was conducted by Robert Rescorla in 1973, in which he performed what's known as a revaluation of the stimuli that were used in Pavlovian conditioning. And by revaluing the stimuli, he was able to tease apart different pathways, or proposed pathways rather, in the stimulus substitution model. And so how did he do this? Well, in phase one of the study, rats were used, and in phase one of the study, it's a typical fear conditioning paradigm. And so rats were taught or learned to fear a stimulus that predicted another stimulus that would naturally elicit fear. This is slightly different, however, because rather than using shock, which is typical in Pavlovian fear conditioning studies, Rescorla used a klaxon. And for those of you that don't know what a klaxon is a very loud noise. These are sirens. And so, in the confines of a conditioning chamber for a rat, sounding a klaxon is extremely loud and extremely startling, such that if you sound the klaxon, it will innately elicit fear and startle. And so in this experiment, the unconditioned stimulus is a klaxon. When sounded, it innately elicits the reflexive response of fear. No surprise there. In this study, then they paired a light. A light would be illuminated for about 30 seconds, and then at the end of that 30 seconds, the klaxon was blasted, and of course that elicited fear. And conditioning unfolded over a series of trials, such that the light was presented, followed by the klaxon, fear was elicited, and then at the end of all this, when they conducted probe trials to determine the extent to which the light, the conditioned stimulus, was capable of eliciting fear, they found that it was quite powerful in creating fear in the rats. And so this is just the conditioning phase. And they got to the point where the rats feared the light just as they feared the klaxon. So the light is now a CS for fear. In phase 2 of the study, they took half of those rats, and those rats in that group, group 1, underwent US habituation. Right? So now what Rescorla is trying to do is get those rats to revalue the klaxon. So half of the rats were assigned to group 1, the other half of the rats were assigned to group 2. Group 2 is the control group. Those rats didn't do anything further during phase 2. They were placed back into their home cages and allowed to relax for a period of time. The rats in group 1, however, were repeatedly exposed to the klaxon. If you recall back to our discussion from an earlier video lecture about habituation, right? Habituation is the repeated stimulation or repeated presentation to a stimulus causes a reduction in the response to that stimulus. And so these rats in group 1 underwent US habituation. The klaxon was sounded repeatedly. And what you expect from this situation is that repeated exposure should cause a reduction in the fear response to it. So following a series of trials in which US habituation unfolded, phase 3 began. And all rats were tested for their level of fear to the conditioned stimulus. Recall that at the end of phase 1, all rats were fearful of the light, that when the light was presented, they all hunkered down in fear. And in phase 2, half underwent US habituation. The other half were placed back into their home cages. In phase 3, they were all tested to see how much fear remained to the conditioned stimulus. I'm skipping over group 1 for the moment because group 2 is as you would expect. They were afraid of the light at the end of phase 1. They didn't do anything in phase 2, and not surprisingly, for group 2, when they were presented the light, they hunkered down and showed a very strong fear response. There is no surprise there. You would expect nothing less. But in group 1, there was a change. When the light was presented, these animals showed very little fear to the light. Their fear had diminished considerably after having gone through US habituation or unconditioned stimulus habituation, repeatedly presenting the klaxon over and over and over again, weakened this link right here. So here's the unconditioned stimulus, the klaxon. When presented, it elicits fear. And so what Rescorla was doing was causing a revaluation of this link in this theoretical associative pathway here. And so repeatedly presenting the US over and over and over again, and what you would expect and what of course is obtained is that repeated stimulation causes a reduction in the reflexive response. And so now in the group 1 rats, this link right here has now been weakened and is no longer as capable of eliciting as powerful a reflexive response, in this case fear. So what happens? The only way to explain the outcome in group 1 is via the SS pathway. If they exhibited a weak conditioned response, which they did, the only way to explain that outcome is via the SS pathway. When the light was illuminated, because it was operating through the SS pathway, when the light was illuminated, it activated the unconditioned stimulus node of the brain, and because this pathway was now degraded, the corresponding reflexive response was also degraded. And so after habituation and weakening of this link, when you present the light, because it's operating through this pathway, the corresponding CR is also weakened as well. If it were the SR pathway that we're operating, it wouldn't matter what's happening up here. The reflexive response would be the same. When you illuminate the light to present the CS, because it disregards this portion of the model here, because it acts directly, if the SR pathway were operating, it should not be affected by US revaluation. But Rescorla discovered that it was. this implies that the SS pathway is operating in stimulus substitution theory. And so this slide here highlights what I just stated previously. Here we can see that because of this indirect pathway, when the light was illuminated, because it seems to operate by activating the unconditioned stimulus node and therefore automatically activating the unconditioned response node, when you devalue the US-UR pathway, it also affects the ability of the CS to elicit a similar response. So moving on, I'd like to discuss the other dominant theory as to why we are able to make these kinds of associations, or why we evolved to be able to make these associations in the first place. And that second theory is referred to as the preparatory response theory. Preparatory response theory states that the purpose of the conditioned response is to prepare the organism for the presentation of the unconditioned stimulus. The purpose of the conditioned response is to prepare the organism for the presentation of the unconditioned stimulus. Why do we do this? Why can we make these kinds of associations? And why is it that novel stimuli come to elicit responses that in many cases are similar, but not always, similar to the unconditioned response? Because unconditioned stimuli, by definition, are important events. Anything that we innately respond to, by definition, is important. Through evolutionary processes, we have evolved to respond reflexively to certain stimuli, presumably because it benefits our survival. So anything that we can do, that our nervous system can do, to prepare us for those events so that we are ready for when those events make themselves known or make themselves available or are presented, we will be better off to deal with them when they are presented. That is essentially what is being proposed with the preparatory response theory. So why do we even need the preparatory response theory if we have the stimulus substitution theory? It would seem, at least on the surface, based on all of the data that we have discussed up to this point, that the stimulus substitution theory seems to do quite well in describing and or explaining the outcome of Pavlovian conditioning. And then we expanded upon that and theorized about the possible pathways and so forth. But what we haven't discussed up to this point are the situations in which the conditioned response and the unconditioned response are not only not the same, they are actually opposed to one another. So again, as a reminder, everything that we've discussed up to this point, and almost everything in the book, the outcome has been the same. The unconditioned response and the conditioned response have been similar. Salivation to food, salivation to tone, eye blink to air puff, eye blink to the illumination of a light, and so forth. So we can see that the stimulus substitution theory fits very well in terms of those experimental outcomes. The CS comes to substitute for the US and therefore elicits the same kind of reflexive response. But there are numerous experimental outcomes, and real-world outcomes for that matter, in which the conditioned response and the unconditioned response are not only not similar, they are actually opposed to one another. And so the experimental study of this and the Pavlovian conditioning procedure that explores this differential outcome is referred to as compensatory conditioning. Compensatory conditioning, our definition moving forward of compensatory conditioning, is simply this. It's a conditioning preparation in which the outcome results in the CR and the UR being opposed to one another. So it's a conditioning preparation in which the outcome of the CR and the UR are actually opposed to one another. So if the unconditioned response causes an increase in heart rate, the conditioned response will actually create a decrease in heart rate. Those are in opposing or compensatory directions. So, for example, a common domain or field of study that examines or uses compensatory conditioning models is in the field of drug addiction and drug tolerance. And so a typical drug tolerance study unfolds in the following manner. So one way to measure drug tolerance in an animal model is to see how able a particular drug is to induce analgesia or pain reduction. So morphine is a drug that causes analgesia, a reduction in pain sensitivity, and that's why it's prescribed. It's very effective at doing that. And so one way to test how effective something is as an analgesic is to use an animal model. And one way that this is done is that rats are placed on a plate that is heated, that's to the point where it is uncomfortable. And you count how long it takes for that rat to show signs of discomfort. And it'll start licking its paws and so forth, showing signs that its paws are now starting to feel pain. And so that is the latency to lick its paws, and that is then your baseline level of pain sensitivity or pain threshold. So let's say, for example, that if you place a rat on a hot plate, you discover on this baseline trial that it takes about 20 seconds for this rat to lick its paws. So that's its threshold. Its threshold for pain at this temperature is 20 seconds. So then on the second trial, you inject morphine. Morphine is an analgesia. It should reduce pain sensitivity, and that's exactly what you get. When you put the rat back on the hot plate, what you find is that on this second trial that has followed morphine injection, this rat licks its paws after 40 seconds. And so now you have induced an analgesic effect through the use of morphine in this rat, and it's not feeling the pain until 40 seconds. So continue to do this day after day after day, 20 trials in which you do the same thing. You inject the rat with morphine, and then you place it on the hot plate. But what you find in this situation is that the latency to lick its paws will decrease. Every day, it gets shorter and shorter and shorter. Right? This is the essence of tolerance, that the effect of a drug at a given dose is less and less effective with repeated exposure. So what you find then is that this rat is becoming tolerant to morphine, and that its ability to serve as an analgesic is going down, such that by day 20 or the 20th trial, this measure of pain sensitivity has decreased such that this animal is right back down to baseline. That by day 20 days of injection of morphine, that by day 20 it's licking its paws when placed on the hot plate after about 20 seconds. It's no better now than it was before this experiment even started. It has now developed a tolerance to morphine. So what happens? How does this happen? How might this outcome occur? Well, if on day 21, rather than injecting the rat with morphine, you instead inject it with saline solution, which is benign. It has no analgesic effects. It has no physiological effects. If you do that, you inject the rat, you do everything the same, but you inject the rat with saline rather than morphine, what you find is that this rat is now super sensitive to pain. If you put it on the hot plate, you'll find that it will start licking its paws after about 8 or 10 seconds. It is now super sensitive to pain. So in the absence of morphine, and you put it back on the plate, you find that it's now super sensitive. Before this all started, if you don't put anything into the rat and place it on the hot plate, its threshold for pain is 20 seconds. But after 20 days of morphine, and then if you on the 21st day you inject saline, which is benign, and you place it on the hot plate, it is now super sensitive to pain. It is hyperalgesic. What has happened? How might we interpret this outcome from a Pavlovian conditioning model? Well, we think about the stimuli and the responses that are present. Morphine is an unconditioned stimulus. It innately elicits a reflexive response. In this case, or it elicits a response. In this case, its response is analgesia. Morphine is an analgesia, and it causes reduced pain sensitivity innately. But things are changing. Every day, that ability to act as an analgesia is decreasing. Is it because the drug itself is decreasing? No, it's because the body is compensating for the effect of the morphine. And so you think about the stimuli that are present at the time of the injection of the heroin. So heroin is the unconditioned stimulus. What kind of signals or stimuli might the rat use to predict the injection of morphine? Well, the same researcher every day, has a lab coat on, takes the rat out of its home cage, brings it into the laboratory. All of these things are stimuli. These are all signals that this rat is about to be injected with morphine. The sight of the needle, the sight of the vial, all of these things become conditioned stimuli. So let's just pick one of them, but there are many. Let's just say the needle is a reliable, and of course it's the most proximal to the infusion of morphine. So let's say the needle is the clearest conditioned stimulus that predicts the infusion of morphine. So on day 21, we have an infusion, but it's not morphine, it is saline. All of the stimuli are there that predict morphine. The only thing that's not there is the morphine. It's been replaced with saline. And so now on day 21, this animal is super sensitive. Why? Because throughout the daily infusions, Pavlovian conditioning was operating. Morphine was taking the animal in one direction, toward analgesia, and the body was developing ways or utilizing mechanisms to compensate for that, to bring the animal back into some kind of balance or homeostatic balance, if you will. And it was using stimuli such as the needle or the researcher or the laboratory as signals that morphine was about to be infused. So these are now become powerful predictors, and in the absence of morphine, the conditioned stimuli are eliciting these compensatory mechanisms. And so if morphine takes you in the direction of analgesia, what's the opposite of that? Hyperalgesia. You think about this as you might think about a shower. You've got hot water and you've got cold water. These are essentially, not quite, but they are, let's think of them as opposing temperatures, hot and cold. Well, no one wants to take a hot shower or a super hot shower. No one wants to take a cold shower. You want to take a warm shower. Well, how do you do that? You have hot water and you compensate for it by adding cold water. So what's happening in our body with the infusion of heroin, or morphine rather, the body compensates for it by kicking in mechanisms that are opposite to it. In the end, it brings us back toward a middle ground. And everything that's associated with the infusion of morphine becomes a trigger, becomes a conditioned stimulus capable of eliciting these compensatory mechanisms. On trial 1, everything is there to trigger the compensatory mechanisms. The needle, the researcher, the lab, everything is the same as it's been for the prior 20 days. And so when these stimuli are present, the rat sees them, it's injected, it triggers these compensatory mechanisms that take the animal toward a direction of hyperalgesia. And the only thing that's missing is the morphine. And so now this animal is hyperalgesic, super sensitive to pain. And this is a process that is learned over the course of conditioning. So you think of this as a conditioning procedure, 21 days in which stimuli are associated with an unconditioned stimulus. It's not surprising then that the body uses those stimuli to predict the infusion of that unconditioned stimulus, in this case morphine, and kicks in compensatory mechanisms to bring that organism back into balance. So that is a typical drug addiction study, and we're going to unpack that in a little bit more detail, and we're going to go back to the opponent process theory of motivation that we discussed in an earlier video lecture. But now we're left with a dilemma. So we've already discussed stimulus substitution theory, and it seems quite capable of describing most of the data that we've discussed up to this point, but it simply cannot explain the differential outcome that occurs in an example that I just described, in an example of compensatory conditioning. Stimulus substitution theory is a theory that says the CS substitutes for the US. It becomes a substitute. It can take its place. And in so doing, it is capable of eliciting the same reflexive response. But we can see here in this example that the reflexive response is not the same. It is opposite. Analgesia and hyperalgesia are opposite of one another. And so the stimulus substitution theory cannot explain this differential outcome. And so because of that, it has come under fire in the last 30 or so years because of evidence that is coming out of laboratories clearly demonstrating compensatory conditioning. So let's unpack that just a little bit further here. We've already discussed the opponent process theory of motivation. Let's modify what we've discussed so far. We just talked about it in terms of emotional responses and so forth. But let's interpret it based on a Pavlovian conditioning perspective. And so again, as a reminder, the model has two processes. You have an A process, which is the primary emotion, the primary response, and you have a B process, which is a compensatory or opposing force. Right? Remember that the opponent process model is these emotional responses that are hedonically opposite of one another. So let's think about that in terms of reflexive responses that are happening within the body itself. So we've got an A process and we've got a B process. The A process, from this perspective, is akin to the unconditioned response. It's the primary emotional response. In the example that I just cited, infusion of heroin, which is an unconditioned stimulus, results in the primary response of analgesia. What happens is that now that the body's been disrupted and it has been taken in a direction that disrupts its homeostatic balance, it is motivated to bring it back into balance using opposing mechanisms. And so we can think of the B process then is this counter effect or compensatory process that's being used to bring our body back into some kind of balance. And then the question then is this, or can we interpret this from a Pavlovian perspective? Is it affected by learning? So the B process again can be thought of as a compensatory CR. If the A process is the UR, then the B process then is a compensatory CR. And we know from our discussions of acquisition, and we know from our discussions of the opponent process theory of motivation that the B process grows with experience, as does the conditioned response. With repeated trials, the conditioned response gets stronger and stronger and stronger. With repeated trials in terms of, let's say, drug addiction, we know that the ability of the body to compensate for that grows and grows and grows as well. So it makes perfect sense to reinterpret the opponent process theory of motivation as a way to explain compensatory conditioning. So in so doing, it's been referred to as the conditioned opponent process theory. So there's a lot of anecdotal evidence to suggest that the conditioned opponent process theory is valid. And so, for example, IV drug users, a lot of work by Shepard Siegel has worked in this field, and he has actually done interviews with people who have accidentally overdosed. And so he would meet these people in the emergency room and ask them about their experiences. What was it about the situation that caused you almost to kill yourself? And in almost every single case, there was something different about the environment, or there was something different about the drug event, if you will. And that makes perfect sense from the conditioned opponent process perspective. Because if the things that lead up to the infusion of the drug, and again, the drug is the unconditioned stimulus, everything that leads up to that can potentially serve as a conditioned stimulus. The people that you're with, the site of the needle, the site of the vials, and so forth. All of these things can become conditioned stimuli. If some of these things aren't there, then the conditioned stimuli is degraded, or the collection of conditioned stimuli is degraded, and therefore the corresponding conditioned response would be degraded as well. And so if people, if drug addicts have been constantly upping their dose to battle against the effects of tolerance, which is quite common, right? As the body gets better able to compensate for the infusion of a drug, they start upping the dose so that they can still feel high. If they do something differently, some of the people that they typically shoot up with, for example, are not there. They shoot up in a different way. Well, then the conditioned stimuli that lead up to the infusion of the drug, some of them are not there, and therefore the corresponding conditioned response is weakened. And the conditioned response is what compensates for the massive drug dose. And so if the conditioned response is weakened, a drug dose that would normally be tolerated leads to overdose. And if they're lucky enough to survive, they've learned something about the factors that lead up to, or that lead into, rather, their drug using experiences, I guess. Okay, so examination of that graphic, that should look familiar. That was from a previous video lecture. It actually comes right from Solomon and Corbett's paper here. We have the distinction between the first few stimulations and after many stimulations, and we can think of drug users as, let's say, the first time that somebody shoots up with heroin versus what it feels like maybe on the 50th time that they shoot up on heroin. And so if you focus just on the top portion of that panel, again, we have that manifest affective response. This is a culmination of what's happening in the body, and it reflects how the person is feeling. And again, as a reminder here, so on the first time that a person shoots up heroin, let's say, let's just use heroin as our example, they get this massive infusion and they feel really high, and then they start coming down a little bit, but they're still feeling great, right? And so this is the primary affective response here. This is the effect of heroin, taking this person in a direction of feeling high. Then the body begins to metabolize and excrete the drug, and so the person comes back down to baseline. But they overshoot, and the next day or so they feel pretty crummy. This is the after effects or the withdrawal effects of taking heroin, but eventually they come back up to baseline and they feel more or less normal. And so that, of course, is trial one, and that's what gets people addicted to drugs. This massive period of time whereby there's this super strong, uncompensated for feeling of being high. What happens, however, after repeated administrations of the drug is that the effect of heroin becomes less and less, such that after trial 50 here, we have a very muted effect. The sensation of feeling high is almost non-existent, and then the person goes into this protracted plateau phase here, whereby they feel just a little bit better than they do normally, and then once the drug is metabolized and excreted, they go into this prolonged period of withdrawal. And so what happens is that this becomes so aversive, the withdrawal periods and the feelings that go along with withdrawal and cravings are so aversive that what happens is that the person starts taking drugs not to feel high, but rather not to feel so crummy. And so that's where they start getting trapped in this cycle of drug addiction. So collectively, just looking at this over here, this is tolerance. This is what happens with tolerance. After you use a drug, assuming that you use the same dose time and time again, the effect of that drug goes down and down and down until eventually it has almost no effect. This is what happens. And so this person is no longer taking the drug to feel high. They're taking the drug so they don't feel like this. So what's happening? Well, based on the opponent process theory or the conditioned rather opponent process theory, right? We've got these two processes, compensatory processes, and a process which reflects the primary process of the unconditioned stimulus, in this case, heroin. And then we have this compensatory mechanism, or this compensatory process that tries to compensate for that primary reflexive response that's being elicited by, in this case, heroin. So what's happening on trial 1? We have the effects of heroin, which are reflected here with this line, which depicts, rather, process A. You infuse the drug here, you get this massive influx of the drug, this drastic and dramatic feelings of high. The drug is in your system, it's fairly constant, and then the body starts to metabolize and excrete it, and then eventually the physiological effects of heroin begin to diminish to the point where it goes back down to baseline. So that's what's happening physiologically, not effectively, but physiologically in terms of this unconditioned stimulus of heroin. So this line here reflects the unconditioned response, or the effects of heroin. The B process, however, right, kicks in a little bit later. Right, this is the first time that heroin has been injected into the body. The body is unfamiliar with this, and so therefore any compensatory effects are slow to begin. And so the body does its best, I guess, if you will, to compensate for it. It kicks in some mechanisms, whatever those mechanisms may be. They might be hormonal, physiological, neurochemical, whatever they are, enzymatic, whatever they are done in an attempt to compensate for what is happening in the body. The body is being taken in one direction, in this case, in the direction of a heroin high. Therefore, these mechanisms would be experienced in and of themselves as taking the person in the opposite direction, of feeling low, of being depressed, and so forth. Collectively, when in combination, when you consider the B process and the A process together, they result in this. Right here we have the infusion of the drug and this dramatic upswing in feeling high. This is reflected right here. Then it goes into a plateau phase. Eventually, the B process kicks in, the compensatory mechanism kicks in, and it begins to draw down this affective response. And so this here is taken away from this, and it results in this. When the heroin is now being metabolized and excreted, it goes back down to baseline, but we see the experience, or the affective experience, of the drug user is that they are now below baseline, and that's because the physiological effects of heroin are gone, but the physiological effects of the compensatory B process are still present, and so this is going unchecked, and this person feels crummy for a period of time. On trial 50, assuming that the drug infusion, or the amount of drug that's being used, is the same, we have the same A process here. Notice that the A process itself never changes. Assuming that the drug dose is the same, the A process is presumed to be identical, trial after trial after trial. What changes is the B process. As we know, as learning unfolds, the conditioned response increases, right? That's our definition of learning, right? A change in behavior, or a change in response. And so what's happening is the body is learning how to compensate for heroin. And so the A process remains the same. But we can see up here, in terms of the affective response, the emotional response, what the person is feeling, this is hardly the same. So what explains this is the change in the B process. The B process grows in strength. This is much stronger here after trial 50 than it was after trial 1, and it's much more immediate. The body is now using signals in its environment, the sight of needles, the sight of a vial of heroin, the sight of people that he typically shoots up with. All of these things are signals that allow this person to prepare for important events. And in this case, the important event is an unconditioned stimulus, the unconditioned stimulus of heroin. And so now, after trial 50, the B process has a lot of practice, there's been a lot of trials, and it is effective at compensating for the effects of heroin. It is just as strong, and it is slow to go back to baseline. What that means for the drug user is that the actual effective response of heroin is minimal, but the protracted withdrawal period that follows is much stronger and takes much longer to get back up to baseline. This person is now a drug addict and dependent on heroin not to feel high, but they do it so that they don't feel crummy. So this feeds right into the preparatory response theory. What is the purpose of the conditioned response? The conditioned response, reflected here in process B, is to prepare the organism for the unconditioned stimulus and the corresponding response that follows from it. And so it uses conditioned stimuli to get the body ready for the infusion of heroin, such that when heroin is infused, it uses signals such as the needle, the person that they typically shoot up with, the apartment that they typically take drugs in. All of these things are conditioned stimuli, and they serve then to initiate the B process, or the conditioned response, which is opposite of the unconditioned response. The body's ready for it. It is prepared. And so that is the essence of the preparatory response theory. If the body is striving to remain in balance, anything that perturbs that balance, it is motivated to kick in mechanisms to compensate for that perturbation. And so if it can use signals in its environment to do so, and to be prepared for the onslaught, or the infusion, if you will, of the drug, it is better prepared for it and better able to maintain this homeostatic balance. And of course, that is necessary for survival. Now, if you think back to the example that I just gave before, looking at the B process here after the 50th trial, right, after this person has been taking drugs for many, many weeks, let's say it's on the 50th trial or whatever, now the B process is strong and powerful and quite effective at drawing down the effect of the heroin. For people that have done things differently, let's say on trial 50, they use the same amount of drug that they've been increasing trial after trial, but for some reason something's different about the environment. The people that they typically shoot up with are not there. The needle is slightly different, or the vial looks different. Well, what's that going to do? That is going to degrade the strength of this compensatory mechanism here, this compensatory conditioned response. And so therefore, rather than it being strong and capable of drawing down the A process, or the unconditioned response, it's muted, it's weak, it looks more like this. And so you have this massive unconditioned response that is unchecked or minimally checked by a weaker compensatory conditioned response, and the end result is overdose. So the conditioned opponent process is an effective way to understand the preparatory response theory. Why is it that we've evolved to be able to make these kinds of associations? Well, because doing so allows us to be prepared for when important events are present. And so that is beneficial for survival. So in summary here, I want students to be aware that when we use the conditioned opponent process model to interpret, in this case, drug addiction, understand that the terms A process and B process can be substituted quite effectively by thinking of them as unconditioned responses and conditioned responses. Just like any other conditioned response, the B process grows with experience. It is learned. Okay, so that concludes then this video lecture on underlying processes in Pavlovian conditioning. I will expect students to understand the difference between the stimulus substitution theory and the preparatory response theory. I will also expect students to understand clearly what's happening, or what the two proposed pathways that might be operating if stimulus substitution theory were correct. And so please be aware of the differences between the SS and the SR interpretation, how they operate, and how the Rescorla study from 1973 effectively answers the question of which pathway is more likely. And also understand what the preparatory response theory is, and how the conditioned opponent process model can help us understand what is happening under the surface. Most of this is covered in the textbook. If you have any questions, please post those questions in the discussion thread specific to this chapter.